Okay, so now we will finish up section 6.3. We just have 3 more properties of logarithms, and we're going to use these properties to solve more complex equations. They're used for condensing and expanding equations. So we mainly practice by expanding, and then we use the condensing more in our equations. So here's our 3 properties. And remember, logarithms are connected really to exponents. So we already know some laws of exponents. So remember, we've talked about if you have these 2 exponents, you're going to wind up adding them together. So when you are multiplying, you wind up adding. So that's what this means right here. If I have the log base anything of 2 things that are multiplied, these guys are multiplied together, I can expand them. I can separate them by the addition symbol. So when we have multiplying inside, we're going to add outside. So look at this law of exponents. Remember when we had these, where I had, I think at one point we did like x to the 5th over x to the 3rd or something like that. And we wound up subtracting those 2. So our division turns into a subtraction. So when we have a division right here, that division can be expanded by subtracting. So division inside, that's your inside those parentheses, means we're going to use subtraction outside. And then the very last one, and this really is one of the most useful laws. We use this all the time. You see your exponent up here? Remember, the reason we do logs a lot of times is to get the exponent down, from the exponent down to the ground floor. If you have an exponent and you have a log, you can just take that exponent and stick it right in front. Okay? So the exponent just moves to the front of the log. So here's our main 3 rules. If you are going to multiply on the outside, if you're multiplying, you can expand it by adding. If you're dividing, you're going to expand it by subtracting. And if you have an exponent, you can just move it out in front of the log. So now we're going to actually use those. It's not until you use them that it really makes a lot of sense. So right now it says use the properties to rewrite the logs. Notice they're all condensed. They're all one, they're taking the log of one thing. So now we're going to expand it out. Okay. So notice this has a division. So instead of division, we're going to write log base 3 of 4p, and instead of division, we're going to subtract. Okay, and then we'll have log base 3 of q. Notice the base is always the same. We're going to for letter A, all of them are going to be base 3. We can expand it just a little bit more because these guys are multiplied. So instead of multiplying, we're going to add. So that's what we do. So we're going to have log base 3 of 4, and then we're going to add the log base 3 of p. And then we keep going, because that was just this part right here. We're going to keep going and say minus log base 3 of q. All right, so let me move that over just a smidge so we'll have a little more room. All right, so now we're going to do the same thing with b. Notice B, we've got division again. So the first thing I'm going to do is take care of that division sign, and it's going to be subtraction, right? Log base z. I put a little thing in the middle of that z so it doesn't look like a 2. But log base z of x to the 5th and y to the 3rd. If you want to put parentheses around those, you can, but you don't have to. Minus log base z of 3. I'm going to keep going because once again, this is a multiplication. So instead of multiplying, again, we're going to do our addition. So we're going to separate those. Have log base z of x to the 5th plus log base z of y to the 3rd. And then we bring that one down, minus log base z of 3. we're not completely done, because when you finish, you should not have any exponents, okay, right? Because the very last law said we're going to bring that exponent right there to the front. So that's what we're going to do. All of these exponents, those two right there, we're just going to bring them out to the front. So we'll have 5 log base z of x plus 3 log base z of y. And then finally minus the log base z of 3. So I've just put that, I put those exponents in front. And we're completely finished. All of these things on the inside, I can't separate those anymore, right? So that's how you know you're finished. All right. This last one, you've got to hold your horses on this one. Notice I said watch out, because it is going to take, it's a rather lengthy problem. Okay, so first thing I'm going to do is I see this exponent. Okay, so I need, not exponent, I see this cube root. So I'm going to rewrite that as an exponent, because we haven't done any cube roots or square roots with logs. Okay, so we're going to keep that, and we're going to write that, excuse me, to the 1/3 power. All right, so now that it's to the 3rd power, now we have power, we can bring the power out front, right? So we're going to bring this and stick it right here in front. So I'm going to have 1/3 of all of whatever I have, log base p of m to the 5th over kt squared. All right. Now I'm going to take this stuff on the inside. I'm going to start slowly pulling that apart. Notice I have a division in there. So that means I'm going to do subtraction. I'm going to leave my 1/3. So I have m to the 5th minus log base p kt squared. I can keep going, right, because this is multiplication. So multiplication, I got to keep splitting it up until I just have one thing that I'm taking the log of. Keep my 1/3, log base p, m to the 5th, minus log base p of k, plus log base p of t squared. Now, there is a major trap here, okay? And here is the trap. Notice that I am subtracting here. What am I subtracting? I'm subtracting this whole thing, all right? So I could think of that as subtracting that whole thing. And the reason I do that is when in this next step I split this up into 2 things, I still want to subtract that whole thing. So I need to still have my parentheses. Why does that make a difference? Because that means that negative is going to change that positive to negative. I've got to distribute it, okay? So let's go back and do that. Now, I can actually do 2 things at once if y'all don't mind. I'm going to bring, while I'm going to distribute that, I'm going to go ahead and bring my 5 and my 2 in front, if that's okay with y'all. So I'm going to put my 5 in front, okay? And then I'm going to distribute my negative here and my negative there. So I'm going to have a negative, my log base p of k, and then I'm going to have my negative 2, because I'm putting that 2 in front, log base p of 2. Is that too much at once? I just brought those 2 in front as well as distributed my negative. Now, I can't leave that 1/3 out there. Okay, I can't make that my answer because I can simplify a little bit more. I'm going to distribute my 1/3. So basically, I'm going to be multiplying my 1/3 by each of these numbers here, and that would be considered a 1. So I'm going to have 5/3 here. Here, if that was just a 1 sitting there, if that's just 1 sitting there, I would have negative 1/3 log base P of K. And then the last one, minus 2/3 log base P of T. Whew! All right. So we finally expanded that as far as we can go. All right. So that's expanding. And that's that's going to be as hard as it's going to get. Okay. Okay. So now we're going to go reverse. Okay. Instead of expanding, notice what the directions say, because you need to know these directions, because on the test you'll get confused. Here it says use properties to rewrite the log as a single log. So when we finish, we should have log base B of something. And that's it. Okay? All right, so we're going to start condensing. I like condensing better than expanding because I'm making it simpler. Okay? So remember, anytime you see a plus, you know, here we said if it was multiply, then that means we're going to add. So now if it's add, if they have an add, we're going to put it back together, right, and have our multiplying. Okay, so I'm going to reduce this to one single log. So I have log base B, and this means multiply, right? K times M. Okay, and now my subtraction, remember my subtraction means I'm going to be dividing. So I'll have log base B, Km is going to be on the top, and we're going to divide it by A. So now we have a single log that put all those together. Okay, we're going to do that 2 more times. Now, before I start doing any kind of division, because I see that and I automatically think, okay, I'm going to divide. But do you see this number right here? So the first thing I'm going to want to do is move that number. Okay, and remember, it is an exponent, so it's going to, when it's out in front, it winds up being the exponent on whatever you have right here. Okay, and now I can do my division. So now I have log base B, and this 2y plus 5 goes on top, and on the bottom will be the y plus 3 squared. And you don't have to simplify that. I mean, you don't have to, you know, foil that out or anything. You could just leave it like that. I like it like that because I don't have to, I know that I can't divide anything. I can't simplify the fraction. All right, last one. Once again, I have a 3 sitting here. So I'm going to put that up on top as the exponent. Okay, so I just moved it up there. Okay, and and now I'm going to move this one up there too. Log base 3 c to the 4th. So that first step, we're just going to move all my exponents. And now I'm going to divide, because that minus says divide, right? So log base 3 of a over b to the 3rd. Okay, and now I'm going to divide again. So my question is, can I just take this and stick it on the bottom like that? Or do I have to write it like this? Log base 3 of a over b to the 3rd divided by c to the 4th. Oh my goodness, that will be a pain. Well, let's see. Let me see what this is to see if I could just take this and move it down there. I would love to be able to do that, but let's prove that that's what I'm doing. A divided by b to the 3rd, and I'm going to divide it by c to the 4th, because that's what this is saying right there, right? So I would have a over b to the 3rd times, and then I just flip that. Remember us flipping that? So I do wind up with c to the 4th on the bottom. So when you see that, you don't have to go through this step. You don't have to do all of this, okay? Because now we've proven that all you have to do, now I'm going to erase that, all you have to do is say a over b to the 3rd, and I'm just going to stick my c to the 4th on the bottom. Okay? There's only one more thing to do in this section, and it's actually really easy. It's just putting stuff in the calculator, okay? So this works when you cannot solve as an exponent. So if I have log, well, I've got one right there. Well, you know, when I have log base 3 of 3 to the second, I don't need a calculator, right? Because I can solve it. But these right here, I can't solve that because I cannot write that 3 as 7 to some power. Okay, so we're just going to use our calculator. But you have to know what to do with the calculator. So you're going to, here, this is the change of base formula or change of base rule. Okay, notice that the base of the log, so that is, that little base of the log goes in the bottom. So think of the base is at the bottom. So I'm going to put my log base 7, excuse me. I'm going to put the log of 7 on the bottom and the log of 3 on the top. In other words, I'm changing this from base A, whatever A is, or from base 7. This is now base 10, which I can now just plug into my calculator. So in my calculator, I'm going to put log of 3 over log of 7. So I'm just going to, let's do that. And I already put that in, but I'm going to show you how to do it. Log of 3, and then hop over, divided by the log of 7, and enter. So 0.5646. 0.5646. This says write as many decimals as your calculator gives. And the reason that we do that is because when you round, when you're actually using logs in the real world, wow, that's a lot to remember. When you're using logs in the real world, you want to go out as far as you can, okay? 564, that's a lot. I'm not going to remember that. Okay, so let me see if I can remember it this way. Hold on. Boop. Give me just a second. If it will. There we go. All right, so let me write that here. So it was 0.5645750341. Holy moly. Okay, so, but the key is when you're plugging it in your calculator, that this one goes on the bottom. Now notice that I had, I could use logs or I can use ln. It doesn't matter. So when you plug it in your calculator, you could put ln of 12 over ln of 9, or you could put log of 12 over log of 9. And you can experiment if you want to. When you put it in your calculator, you're going to get the same answer, whether you use ln or log. So I'm going to use ln. ln of 12 divided by the ln of, what did we say? ln of 9. Sorry about that. ln of 9. So, what we're going to get, let's see. Me be able to write it from my calculator into my notes. So that will be 5.4598979633. And then this one, this just proves that it does not matter what you put in there, whether they're decimals or not. You just stick that in your calculator. 12.7 and 5.8. All right. 12.7 and 5.8. Key is you got to be consistent. If you use logs, you're going to want to keep the logs. If you use LNs, you want to do LNs. Okay, so you don't want to have the top be logs and the bottom be LN. I don't know why you would do that, but some folks might. So just wanted to make sure you do that. All right, so let's write that down. 1.4458577768. And that's it. So, oh, I almost forgot. The word of the day for your quiz is hurricane, because that is why we are not in class today. Hope y'all have a great day and stay safe.